Welcome back. Going to do exponential smoothing forecast at this point. Now, if you look, the exponential smoothing is very different than anything we've done so far if you don't look too close, right? Notice that this object, alpha, is just some number between 0 and 1. That's where it's restricted to be. If alpha were equal to 1, notice that this would be 0, so everything back here would be 0, and alpha is 1, I'd be right back to the naive forecasting method. All right, well, what does this forecasting methodology have that it resembles moving average or weighted moving average? Well, because of this f sub t showing up in here, I have information from the past contributing to my forecast for next time period. In fact, how much information from the past? Well, in this particular instance, every time period in the past is going to matter in my forecast. Now, let me keep that thought in mind as I move forward. First thing I need is an initial forecast. So I need, for example, a forecast in time period 1 for time period 2. Well, I'm going to just use the naive forecast for that. I can't do this, because I have to start somewhere. I have to have an initial f sub t. So the initial f sub t, somehow I got to get it. Let's just use the naive forecasting method. I do that once, and then all of a sudden I can now use this process. Okay? So in time period 2, I can construct a forecast for time period 3. And if I follow the instructions in the equation, that would be alpha, so this thing, and I'm going to make that an absolute reference, times what happened with actual demand in time period 2, plus 1 minus alpha, again referring back to this alpha F4 because it's going to be an absolute reference, times my forecast from the prior period. So what I actually have is called a linear combination. I have a linear combination of the actual demand from the prior time period and the forecast from the prior time period. So I push return, and there's my first forecast. Now this forecast uses information just from the prior time period. Whoops, does it? Just from the prior time period and the time period before that. Okay. Let's copy this and let's look at the forecast here. The forecast here uses the prior time period's actual data plus this forecast from the last time period, which included data from the previous time period, and the forecast for the previous time period, which included data from the previous time period. See, all of that is contained in this number 80 in cell C4. All the history is contained there. All right, I can continue to copy all the way down. So that I have my forecast, and I don't like carrying all that decimal. Right, let's see if I can, apparently Excel's not liking me right at this moment. Let's just carry 1, that's enough. Okay, so what does this tell me? This tells me that the forecast in time period 16 is what actually happened in time period 15, plus the collection of everything that happened in all the prior time periods. That's what's showing up in my forecast. Draw a picture, just like we have before. Insert the picture using chart tool. Okay, well, notice what this picture looks like. Well, let's see, it's smoothed out, kind of like the MA3 process did. Could I make it so that it's not so smooth? And the answer is yes. Play around with this alpha. Let's make alpha 0.9, so that makes the last time period very important. I think what you'll see is we'll get the bumps back in the forecast. Yep, there they came. So the bumps are back in. In fact, if I make that even larger, the bumps will be even more pronounced. If I make alpha smaller, it becomes more like the MA processes. Yeah, progressively worse forecasts. as I make alpha closer and closer to 0. So yeah, I like setting up these spreadsheets in a way that we can play around with them. And you just go in and you change that 0.9 a few times and just see what happens as we do our forecast. Now, by the way, we'll find out later that we don't want an exact match. That doesn't help forecast out here. What it does do is help make our measurement of errors smaller, but I don't know if it's going to improve my forecast. All right, there is our, let's see, what is our process? The exponential smoothing process. So hopefully this is helpful. I have one more video in this series, and that is for a trend adjusted exponential smoothing. Thank you.